I'm going to go over this short FRQ right here. So part of this is a KSP problem, and the other one, the other part deals with lattice enthalpy. So the first one says calculate the number of grams of magnesium hydroxide that is dissolved in 100 milliliters in a saturated solution. So, and it gives the KSP value, so automatically you should know that you're going to be doing something with that probably. So I know magnesium hydroxide, if I dissolve it, because we're talking about KSP and that deals with solubility, if I dissolve it, I'm going to make magnesium and 2 hydroxides. So I'm going to make that. Now, I also know that the KSP is equal to magnesium to the first multiplied by the concentration of hydroxide to the second. So it's asking how many grams of this is dissolved in 100 milliliters. Well, if I can figure out how many moles per liter I have of my magnesium, then I can figure out how many grams are dissolved in 100 milliliters of water. So really what I need to know is I need to know how much magnesium is released into the solution when I dissolve this compound. So the first thing I'm going to do, I'm going to set up an ice table. All right, I'm going to get rid of this because it's not included in KSP because it's a solid. Well, initially there should be 0 of both of these, and then I'm going to add some amount of the magnesium and twice that for the hydroxide. So I have X and 2X, and really what I'm trying to do is I'm trying to find what the value of X. Well, I have the KSP value, that's 1.8 times 10 to the negative 11th. So at this point, I'm going to plug everything into my K expression and solve for X. So my KSP is 1.8 times 10 to the negative 11th. That's equal to X to the first multiplied by 2X to the second. And this is usually where people go awry. So 2X squared will actually give me 4X squared. And then I still have the other X over here. So it's really going to be 4X cubed. So I have 4X cubed, and that's equal to 1.8 times 10 to the negative 11th. So if you divide both sides by 4 and then take the cubed root, you're going to get, for little x, you're going to get 1.65 times 10 to the negative 4th. Okay, so what does this represent? Well, first of all, I know it's a concentration, so moles per liter, and that's what little x is. So the concentration of magnesium in that solution is going to be 1.65 times 10 to the negative 4th moles per liter. Well, if I look, for every one of these that I make in my solution, it took one of the original salt. So the amount that can dissolve in that solution is the same thing because it's a 1-to-1 ratio. I make one of these for every 1 hydroxide, magnesium hydroxide, that dissolves. So now I know what my concentration of the magnesium hydroxide is at saturation. Well, I want to know how many grams that is in 100 milliliters. So remember, molarity is a conversion factor. It's a conversion factor between moles and liters of solution. I want to know how many grams there are. Okay, I have a molarity, which is a conversion factor. I also know that I'm starting with 100 milliliters. That's going to be my starting point. Well, once I figure that out, well, how many liters is that? Then can I figure out the number of moles? Yes, I can, because I have molarity now, and then I can figure out the grams. So my 100 milliliters, well, that's really just 0.1 liters. So convert that to moles using your molarity. You have 1.65 times 10 to the negative 4th moles for every 1 liter, and then go to grams. And it tells you the molar mass here. It's 58.32 grams. All right, so then when you get this, you're going to get 9.6 times 10 to the negative fourth grams. Okay, and I am going to have two significant figures here. So I have my grams points. You get 2 points for this. So let's say that you gave the correct answer and you showed work, you're going to get 2 points for that. Okay, now let's say that you don't get the correct answer, but you did calculate this part out correct, then you would get the point. So 2 points automatically for calculating this with showing your work, and then if you don't get this, then you get 1 point for just calculating the molarity, or the molar solubility, essentially. All right, so now let's look at that second part. The second part is talking about lattice energy. So it gives you 2 lattice energies or enthalpies for these compounds, so magnesium hydroxide and also strontium hydroxide. Well, it takes more energy to separate out the magnesium hydroxide versus the strontium hydroxide. It says, explain why in terms of periodic properties in Coulomb's law. So why is this higher than this one? Well, the only difference between these 2 compounds is the cation. So when we compare magnesium to strontium, well, strontium is lower on that group, which means that this is larger than this. So you get a point just for identifying the fact that strontium is going to be larger than magnesium, or you could say that magnesium is smaller. Now, why or how does this relate to these numbers? Well, it takes more energy to separate the magnesium hydroxide. Well, it's because it's smaller. So it takes more energy to separate these out. Because it's smaller, it can be closer to the hydroxide. It's closer to the hydroxide, which means it's more attracted. So you get a point for identifying the fact that, or when you compare the sizes, you get another point for explaining how this deals with the numbers. The fact that magnesium is smaller means that it's more attracted to the hydroxide.